All right, folks, we'll start up momentarily. Give a few more people to give another minute or two for folks to walk into the room. Has anybody seen Jeffrey? Is he in the room? Jeffrey Zhang?
Yes, I am here, but I'm fine. I'm just sitting
you
in.
can, you can sit up here.
Oh, okay.
No, we didn't know if there was anyone available. You can take it.
There's two chairs, so both of you are welcome.
You sit over there by the. You take the monitor. Oh, okay.
Lenny, you're going to run the slides, right?
Yes.
Okay. So I just
Can you see the agenda slide, the 121 Dublin slide? Okay, so why don't we get started? Welcome all to MBONED. We'll start with the note well. Everyone, please remember that we are abiding by the standard IETF process for intellectual property. If you haven't already read this, please do. And note really well, we aim to be professional and courteous to one another. In terms of meeting tips, by now I'm sure you guys are all well aware of this stuff, but for those of you in the room, please make sure that you are signed into Meetup, because that is effectively our blue sheet, and it also allows you to join the queue. And we ask everybody, even if you are in the room and you're walking up to the microphone, please join the queue before doing that. That way, folks remotely have an equal shot of joining the queue. For remote participants, again, make sure your audio and video are off unless you are speaking. And we have Jeffrey, who is a delegate in the room, as well as Kyle, who has graciously agreed to take notes today. So we are very appreciative. Thank you both. All right, in terms of the agenda, we have a action-packed agenda today, completely full. So we're going to try to make sure we are vigilant in terms of time for each of the presentations. So we please ask everybody to present. I'm going to try, hopefully, if I remember, to set the timer for each speaker, so that helps them, but I may not remember fast enough. So please keep a little bit of time available for questions. This is the agenda. Anybody see anything that is missing, needs to be added? Any bashes to this agenda? Okay, moving right along. In terms of
Lenny, sorry,
yeah.
Max. Could we? So Louis and I talked. Maybe we can move his talk before my MC quick talk, because his talk is. So my talk would basically have a part about bringing people back up to speed, but it's also kind of his talk, so it would make sense to have them together and have his first and then mine after that.
Okay, and you said Louis is happy with that?
Yeah.
Plan.
Yeah.
Okay. All right. We'll switch that around. So Louis will go right before you. I did want to keep you guys together sequentially, since you both are speaking about similar topics. So that's great. And we have some really great topics. So we're excited about this today. In terms of active working group documents, the telemetry draft was published in August as RFC. So congrats to those. Congrats to those co-authors. Thank you for your work in that. The Yang models and any co-authors for the other three, the Yang models, the ingress failover, or the AMT Yang drafts. Anybody want to get up? And Sandy, you may be a co-author on all three. Any updates to any of these three docs that you would like to share with anyone?
It has been updated according to all the comments received. So maybe it can be moved forward for director to review, or moving to ISG or something else. Right?
Which draft are you referring to?
About the multicast Yang model and the redundant ingress failover.
Okay.
Yeah.
So do you believe that they are ready for working group last call?
Yeah.
Okay. If you could just shoot an email out to the chairs and or the group mailing list to request working group last call, and we'll get those kicked off.
So I need to send the mail in the mailing list to request, right? Okay.
Unless you see us do this in the next couple days, it might be because we forgot. So a gentle nudge would help us.
I can wait for 1 month or 2 months and call you. Okay.
You could wait a couple days, and we'll try to get it done.
Okay.
Okay, and other documents, the adaptive unicast and multicast, that's going to be, Yishang is going to speak about that today. And Jeffrey, do you have anything to add about the non-source routed SR draft?
We have not done any update on that yet, but it's an informational draft that represents the views from the co-authors. We presented it twice already, once in PIM, once in MBONED, after we rehomed it to MBONED. We have not received any rebuttal comments. So I hope that people are fine with our opinions. So I just want to call out again here that please, if you have different opinions, please speak up so that we can consider, we can discuss, and then we may change our drafts. If you don't speak up, at least from the co-author's point of view, it's we would like to get it adopted. It represents their views. We believe it's quite mature. So please voice your opinions. Thanks.
All right, Jeffrey. Yeah, if you want to send a message to the mailing list as well, to that effect, that'd be great. Okay. Anything else anyone has before we get started? Okay. Yisong, are you in the room? You want to come on up?
I'm here. Yeah, I'm here.
All right, let me bring up your slides. Okay.
Hello, everyone. This is Yisung from China Mobile. Today, I will present the adaptive unicast to multicast forwarding on behalf of my co-authors.
I'm not 100% sure that works.
Okay.
Okay.
Hey?
Did it?
Oh.
You're not moving the slides, right, Lenny?
Well,
You're
the slides are not presented, not being presented from here, so that remote will not control Lenny's machine.
Okay.
Yeah, if you want to just tell me when to advance, I'll do it for you.
Okay. Please, next slide, please. Yeah. The background of this mechanism is that the current we have many P2MP internet services, and the internet services system do not support the multicast. It will need a large scale transformation for the multicast upgrade of the service system, but the service provider lack of the driving force. They are not willing to upgrade their systems. On the other hand, and through the unicast forwarding and the bandwidth pressure on the carrier network, it's enormous. So the redundant traffic for the same service, so the thousands of or even millions of the identical unicast traffic between the edge service nodes and the end users, like the short video live, like the YouTube or TikTok. So the difficulty in improving the network quality of own services while occupy the bandwidth of other services. As we know, like the short video live, it often use the HD quality, or it will not provide like the 4K or 8K. That's quality video. So next slide, please. So in this draft, we provide a mechanism for the unicast to multicast. So based on the existing multicast forwarding mechanisms, so that like the PIM or the MPLS or the beer, etc. So the unicast service packets with the same characteristics are converted from the unicast to the multicast, and then sent to the end users. We just convert the packet in the carrier network, not change the packet from the server to the ingress and the egress to the end user. So firstly, for the internet service system, if the service provider want to subscribe this service, it will subscribe to the controller to make a service ID, and it will insert the service ID in their unicast traffic. Whatever the service ID, the format is that. And in the ingress PE, we will configure the adaptive or optimization policy and specify the mapping relationship between the unicast flow characteristics, like we define the service ID. And the multicast IP address and the end user IP address. So at the beginning, the ingress PE forwards the service traffic along the unicast forwarding path. And after receiving the stable service traffic, the ingress PE will send a notification to the egress PE to trigger the egress PE to send the multicast join request, and will establish the multicast tree. And the egress PE will add the mapping relationship for also the multicast IP and the end user IP, because it will convert the multicast traffic to the unicast traffic again. So next slide, please. Okay, and so this is the packet forwarding process, and from the service system to the ingress PE, we use the destination IP is use the user IP, that is the unicast IP. And from the ingress PE to the egress PE on the carrier network, we use the multicast IP. And the conversion depend on the mapping relationship. And the egress PE will restore the multicast traffic to unicast traffic, and the destination IP is replaced by the end user IP. So next slide, please. So for the identification of the unicast traffic, we can use the packet information like the source and destination IP address and the TCP or UDP port or DCN, DSCP or the IPv6 extension header or the ARN or APN ID. That means that some service ID. And for the service identification in the ingress PE, we can use some AI recognition or the by the controller or the application aware or even DPI. And we can get the target traffic for the unicast to the multicast. Next slide, please. So this is the updates from the last presentation. The first one is that we have clarified the difference between the AMT and this mechanism, because last presentation many people may be confused with this mechanism. The second part is that we add the section 2 for describe the use cases, and the third part is that we added the description for the identification of the unicast traffic. Next slide, please. So we co-authors want to get more feedback from the working group, and we also ask for the working group adoption. Thank you. That's all.
Great, thanks. I see a couple folks in the queue. Tim, Jeffrey.
So what's the advantage of doing this?
Sorry, Jeffrey. You
There is an order.
Tim,
Oh.
Tim is first.
Tim Chan Jisk. So can you go back to slide 1, I think it was, or 2? Oh, sorry, Lenny, can you go back to slide 2? So yeah, the internet service systems lack the driving force, and yet the network provider has the enormous pressure. In these sort of scenarios, this is, I guess, such a general multicast business problem, can the ISP not put some of that pressure onto the internet service system to actually send multicast? In the situation you have here, this service system is sat there right near this edge that looks like it wants to do the distribution. All it has to do is send source-specific multicast rather than unicast. What's the problem that's stopping that happening?
Because for the internet service provider,
You're writing something, Lenny. We can hear you.
Huh?
Sorry about that.
It's all right.
Okay.
Sorry, go on.
Because for the internet service provider, they not much care care the network cost, because the network bandwidth cost only in a very low rate in their own cost. But this bandwidth pressure is much more in the carrier network for the operator like us.
Okay, so you're saying it's happening more in the backbone rather than the edge, but it's still all got to come from the edge, the sourced traffic. I'm a little confused, but okay, never mind. Sorry, go on, Jeffrey. So it's okay.
Sorry, I was really confused by the display of that queue. I thought Anyway, sorry. So my question is, now if you imagine those PEs who is replicating traffic to the end users, if those PEs are CDN servers, then what's the advantage of this method over the traditional CDN method?
You mean the
Right. Today,
the system is the CDN?
so here is the internet service system. Is that a video source or is that a CDN server?
It may be. It can be a CDN server, but today we use the CDN distributed CDN to
Right.
yeah.
Right. So what if those where you draw the PEs, if you put your distributed CDN server there, wouldn't that be easier? Because now the content providers and CDN providers, they all have this existing solution there. So if they just put their CDN server next to the PEs, then it seems to be easier to for them to just keep the existing model.
But even the distributed CDN server, but for the end user, it also can be thousands, even millions, because in the in the in the channel in China, the end users, even in a city or in a province, there are this level user numbers.
So if where you draw the internet service system, if that's where the CDN server can go as far as possible, then this perhaps makes sense. But as long as the CDN servers can be distributed to where your egress PEs are, then they basically solve the same problem using the existing solution. That's my thought.
Oh,
Mankamna Misra, Cisco Systems. So there was a white paper named Multicast Assisted Unicast Delivery. So you might want to see what benefit we are getting, or it is something similar or something different. You may want to have a differentiation here. What exactly we are trying to do.
Sorry?
There is a white paper, Multicast Assisted Unicast Delivery. It is for the CDN use cases, what Jeffrey was mentioning.
Oh, I haven't seen that paper. Can you send me the link? Okay.
Yeah, man. If you could share that in the text in the chat, a link to the MAUD draft or MAUD doc. Torless, only if it's super fast because we are already behind.
Yeah, I think it would help to outline a little bit more detail about a typical use case here, right? So because I think a couple of the questions were guessing at how it looked like, right? So if, for example, this is from the IP network service provider itself, its own IPTV server, right, which is integrated with the network. And then you got all these crappy Android devices that cannot receive multicast well for various reasons, and they want to get unicast there. Then you have good collaboration between that server and the network, and then there are all type of solutions possible, but that context isn't clear.
Great. So, Yisung, if you'd like to, if you could send the messages, send comment or send your comments and questions to the list, and let's take this discussion to the list.
Okay, thank you.
Great. Okay, next up is Jack from BSV. Is Jack in the room?
Yeah, I'm here. It's Jake, actually.
I'm sorry, Jake, my bad.
Yeah, no worries. How's it going? Thanks for having us. A couple of colleagues sitting back there too. We're all from the BSV Association, which is the steward for the BSV blockchain. And so what I want to do today is take you guys through some stuff that isn't talked about a lot in terms of the blockchain and stuff that you're usually exposed to, and hopefully give you an idea of how we're approaching it and what we think the value of it is. Micropayments is definitely the central concept. Lenny, can you go to the next slide? So this is just a little bit about us and what we do. We're a nonprofit. Our job is to steward the protocol, make sure it doesn't change, because if you have a changing protocol, then companies that are building on top of your protocol are going to have breaking changes, and that's not good for business. Open source software we do, and some programs and governance, public affairs, that type of thing. You can check out our website if you're curious to know more. Next slide, Lenny. And so I want to just take you guys through kind of the thought process here. So information theory, I'm sure many of you are familiar with this. Information is essentially a measure of uncertainty, and then you have entropy, which is quantizing that, and noisy channel coding, which we're not really discussing today, but it's good to include in there. And so we've all heard the term that data is the new oil. And then if you extrapolate that a little bit, it's refined data that becomes information. And so the more you refine the data, the more you reduce uncertainty, and then you get more and more information. And so next slide, Lenny. So George Gilder looked at this and he thought it was pretty interesting, and then he applied it to money. And so his insight is, if you look at how people are spending their money, you get a really clear understanding of what their preferences are, their needs, their values. And so that becomes kind of streams of information. Some real world examples like recommendation systems, Netflix. You guys are all familiar with that stuff. Next slide, Lenny. And so I'm sure most of you are familiar with this book too, Thinking Fast and Slow. System 1 is low effort, quick thinking. It's intuitive. System 2 is the slow type of thinking. And so what we want to do, or what we're doing with micropayments, what the value of them is you get a really high resolution look at how people are spending their money. The more micropayments are being used, the faster the money is traveling through the system, the clearer your understanding gets. And that's not really talked about. Most blockchain stuff is focused on price, or it's focused on financial instruments, but it's so much bigger than that. The blockchain is just kind of the anchor of the system. Next slide, Lenny. And so this is the system that we built and are continuing to build. So it's the BSV network, and we really strongly adhere to the original Bitcoin protocol, peer-to-peer electronic cash. So we want to get as many micropayments as possible, and then we have an unlimited block size. So we stick as many transactions in the block as possible. We have as many micropayments going as possible. And then you get this really elegant incentive structure that starts to form. And it's anchored by proof of work, which is, it uses game theory. And so nodes are competing to win the right to put the next block on the chain. And because they're competing, then they invest in their infrastructure, they reinvest in their infrastructure, and that makes the network better. And then people's experience gets better, so they start doing more micropayments and using the system more, and then it creates a nice positive feedback loop. And that's what we're going for here. We want that high resolution information, and we want as much activity going through the chain as we can. Next slide, Lenny. And so why do we need IPv6 to do this? Well, the biggest reason is the address space. So if we want all of these systems doing these high frequency micropayments, they all need their own IP address. They need to be able to talk to each other directly. No NAT, and obviously end to end. And the other really interesting part about IPv6 is it actually pairs really well with the way Bitcoin transactions are structured. So we're looking at ways of either incorporating packets into transactions or incorporating transactions into packets, maybe in something like a next header field. Next slide, Lenny. And why do we need IPv6 multicast? Because when you have so much network activity happening, you want to find ways to reduce that as much as possible. And it also provides simultaneous delivery, so you're not affecting the incentive structure that the nodes are following. Because if you have high frequency payments and then one node is getting the information before the other nodes, yes, they have to propagate it, but that could become an advantage and it throws off your incentive structure. And then the last bit is the addresses. So this is something we've been playing around with a little bit, where you can construct a multicast address. So we follow section 8 of the white paper, SPV. You submit a transaction, it gets timestamped, and then you get a Merkle path back, and you're able to pass the Merkle path directly to another party, P2P, and they can run Merkle proof to ensure that that transaction is actually in the blockchain. And yeah, and then where was I going with that? Yes, okay. So the cool part about multicast addresses is you can take the transaction ID, and then once it gets timestamped, whoever needs that Merkle path back, let's say there's more than one output in the transaction, they can essentially subscribe to get to the same group address that's generated by the transaction ID, and they'll get that information. Next slide, Lenny. And then smart contracts. This is now going into just features that we have with Bitcoin SV. We have a very well-developed smart contracting platform. Scrypt is a great company that uses it and has built a lot of it. We've done Conway's Game of Life on the blockchain. Everett CPU is a developer of ours that's essentially built a CPU on the blockchain. We use Bitcoin script, so it's all pure Bitcoin being processed by the nodes. You can do amazing things with it. And then there's the infamous Turing completeness. We've proven that now. Next slide, Lenny. And so this is another thing too. I talked just briefly earlier about block size. And one of the biggest reasons you want an unbounded block size, you want to stick as many transactions into your blocks as possible, is because it reduces your carbon footprint. Because proof of work, the computation that's done to find a proof of work doesn't change. It doesn't matter how many transactions you have in a block, that work is essentially the same either way. So the more transactions you get into the block, the more efficient the blockchain becomes. And as the blockchain grows and miners reinvest in their infrastructure, it forms another positive feedback loop. So it actually gets less carbon intensive over time as it grows. Next slide, Lenny. So this is another feature that we added earlier this year. This is digital asset recovery. And what we've done here is it's essentially a way for people to get their currency back or their coins back if they lose their keys. So as long as they can prove that they own that Bitcoin or they own that BSV, they can submit that proof. That it has to be signed off by a court, but they can submit that, and then those coins will be reassigned to a wallet or address that they control. Then here's some use cases. 163 applications. I kind of got cut off there. But yeah, we're working with a number of companies. It's growing all the time. We have some really great projects that we're working on right now. And yeah, if anybody has any questions, still quite a bit of time left.
Mike, you're up.
Mike McBride, FutureWay. Thank you, Jake. I love everything about this. We had a blockchain related presentation last IETF and it was equally as interesting. So thank you for doing this and coming. So you have your own blockchain. You have your own distributed consensus system, which you're competing with like hundreds of other blockchains as well. Is that correct?
Yeah, well, we follow the original Bitcoin design. So we follow the protocol as it's laid out essentially in the original code and the white paper and the original writings of Satoshi and kind of how all of those things fit together.
Okay. And the IPv6 multicast comes in, it's between the nodes, all the nodes that you have in the network. Is that where?
Yeah, and even beyond that. So I didn't really go into it there, but the infrastructure is essentially it's 3 layers. So you have your wallets, which is on the edge, and then overlays kind of fill in the middle, almost like a middleware, and then the node network is at the center of highly specialized nodes. So they're big. It's like big corporations, big companies that are the nodes.
Okay. So you don't get into the wallets themselves, as far as I know, don't have IP addresses. They're just using these alphanumeric characters. It's the network itself, the Bitcoin network that's using the IPv6 multicast.
Yeah. So
whether it's the overlay or whatever, yeah. Okay, I think that kind of makes sense. We can talk more. My next question, and this will be the last one, is to Lenny. I mentioned this before, since this is something that I am excited about. I'm excited about this like I was with multicast 20 years ago, just kind of from a research perspective. But I am planning to, as I mentioned before, create a draft that kind of talks about the benefits of this and in using multicast for these kind of scenarios. Is this something that would fit within the MBONE charter today to do these kind of an actual draft, or would the MBONE working group need to be rechartered to be able to fit using this kind of an application of multicast?
Oh, that's a good question. I mean, we are chartered to handle use cases for operations. So it's been a good week and a half since I read our charter. But I think so. So I would say bring the draft, and it depends on what the draft says exactly.
Okay.
But multicast deployment use cases, I think, is well within our charter. That's the whole point of MBOND. So without re-perusing the charter, I would say bring it.
All right, thank you. And thank you, Jake.
Thanks, Mark.
Unless anybody else has any objections, Tim, or has any other thoughts about another working group this would be a better fit in, but I would think that this would be.
Well, we have a AD sat here. Maybe he's got a comment before I make mine. Yeah, I think you're allowed to come. It's okay.
I mean, I think it depends wildly on what the document actually says, right? We'll have to look at the charter and what the document says and then figure out if it might be.
Fair enough.
Okay, so Tim Chan, JISC, can you clarify, I mean, one of the nice things about multicast group addresses is, and the addresses, you can very easily put anything in to create them. What is it exactly you're putting into the group address? Is it a notification to everything in the system for any transaction, or is it a specific transaction wallet or whatever it is? I really don't know how this stuff works. Is it something to do with a specific wallet that you can then get updates on? What is it exactly?
Yeah, so the main application will be communication between the nodes. So when a transaction is submitted to the node network for timestamping, If that's multicasted, then all of the nodes get it at the same time, which they all need it anyways. So if right now the way it's working, if it's unicasted, then that node that receives it has to propagate it, and it's in their interest to do so, because when they build a block, they have to distribute that block, and they only get the rights to that block if the other nodes start building on top of it. So they have to make sure that they all have the correct information, and this streamlines things really, really well.
Okay.
And the other purposes, or the other use cases for it, is we use subtrees for part of the building process. So we use a Merkle tree, and then while that Merkle tree is being constructed and the nodes are looking for a block, we send the subtrees of the Merkle tree around. So there'd be a group address for that likely, and then there'd obviously be one for blocks. So transactions, subtrees, blocks, and any sort of specialized transaction too, or alerts.
Okay. Yeah, I mean, they would still not necessarily all get it at the same time. So the message sort of has to propagate through the tree, but at least in theory, if everyone's subscribed, they all should, as long as it's a reliable multicast transport, they should all see it. So the other question is, what multicast network do you have deployed or envisage deploying to allow the messages to propagate? I mean, I understand from people that work on multicast that there are these private multicast networks for financial systems and so on. Is this just going to be another one of those? Is it that kind of thing, or are you going to use some other multicast infrastructure?
Well, we're open to trying different things. That looks like it might be the only option at this point, but yeah, it's definitely great talking to you guys, because if there's anything else that we could do, we're open
I think
to
this
it.
group is very interested in new applications for multicast. So yeah, sure.
So
Thank you.
thanks, Tim.
Yeah, so maybe really following up on that, I was wondering really what's physically the multicast in the network, right? So, I mean, it comes from a wallet. Is that this wallet? Or, I mean, I really don't get the physical nature of the network that you're using, but it sounds almost as if you're in the planning stage right now. But you probably already have networks, you're just not using necessarily all the multicasts on them, right? So any more detailed insight what the physical networks are that you have or could have, then yeah, we would be happy to explain to you how to best, you know, what type of multicast you configure and all this stuff.
Awesome. Yeah, that would be great.
Oh, I did, yes. Sorry. Oh, yeah, and I'm missing also, this is so green, it always falls off. Tallest accurate, yeah, sorry.
It's in the queue.
Yeah, so
So what's the physical network now, right? So I mean, this is probably working without multicast already. So what's
right,
a
yeah.
typical example how it physically looks like?
Yeah, so it's at if you just pare it all down, it's essentially a time-stamping service. It's a time-stamping service. So you create a transaction.
No, really physical network in terms of, you know, is this all sitting in a single data center room with a single switch in the middle, or kind of, you know, what's the physical network nature here?
No,
About
it's
hundreds of routers spread out over the world, right? Somewhere in the middle, you know, that level really.
Yeah, somewhere in the middle. I don't know, because those are run nodes are separate companies from us. They have their own infrastructure.
We can take it offline, right? But really putting together that type of information or so, I think would be a great amendment to the draft so that we can start having opinions about really how to apply multicast. So please feel free to reach out to us so that you can add that information.
Absolutely. I'll reach out to some of those companies.
Okay, and as we, Jeffrey, I saw you wanted to enter the queue. Was there something you had to add?
No, I should not be in the queue.
Okay, great. Well, thank you very much. This is really fascinating, and this is definitely, I think, an area where, as Tim said, we're always looking for use cases. So this is a really interesting use case, and we'd love to hear more about it. So feel free to share things with the mailing list, and Mike, I just looked through the charter, and we are receive regular reports on the current state of deployments of multicast technology, create practice and experience docs that capture the experience of those who deployed and are deploying various multicast technologies. So I think something along those lines would fit very nicely into our charter. So we welcome this work.
Thanks, Lenny. Thanks for having us, guys.
Okay, Luis, if you'd like to come and join.
Hello. Yes. I asked for the slides, but I don't know how it works.
Do you not see it?
No, I see the slides, but I asked to get the slides, to get the control, but I don't know how it works. But
Oh, okay. Hold on. I know how to do this, I think. I am going, there's a button here. Anybody remember how do you grant?
otherwise, it's okay. I can just ask to go to the next slide.
Yes. Pass slide control. There you go. How about now?
Sorry, I just canceled when you gave me, so I just asked again. I'm sorry.
All
I'm
right,
sorry.
Let me give first the slides. Did the slides just disappear?
Yes.
Okay. Well, let me fix that.
Okay.
All right, and I'm passing control to you. How about
Wow,
now?
perfect. Yes, it works.
All right.
I think. I try to go to the next slide. I'm here. Doesn't seem to work. Okay, so it's supposed to work, but it doesn't. So I'm sorry. I will have to. You will have to reshare again the slides, and I will just add to the next slide. I'm sorry, Lenny.
No worries.
I'm
We'll
sorry.
get that next time.
Yep. At least I tried.
That felt like it should have worked, but
Yes.
okay.
Okay. So next slide, please. Okay. So hi guys. The idea of this draft is to propose another way to integrate flexible multicast inside QUIC, which is a transport protocol that has been standardized a few years ago. I made quite similar presentation at the QUIC working group earlier today, but I will go through the basis of what is it about. So I know there is an existing draft that was initiated by Jake Holland, and Max will talk about it later. The idea of this draft is just to present a deeper overview of how we could integrate it inside a QUIC. But of course, all the things that are explained in the other draft are still of importance. So here the idea is just to present how we could implement multicast using multipass QUIC, which is an extension of the QUIC protocol, and using our experience from our implementation. So next slide, please. So just a quick reminder, the QUIC protocol, so it's a protocol which is designed to replace TCP for the web. It has a lot of features, for example, multi-streaming, so you can have parallel streams to avoid head-of-line blocking. The security is integrated directly in the transport, so you don't have to add it on top of the protocol. And it's already serving a lot of HTTP requests in the world. So you have a diagram of how QUIC integrates compared to TCP. And what is also interesting is that QUIC runs above UDP, which is important to do multicast. Next slide, please. So then the QUIC working group is standardizing multipass QUIC. Basically, the idea of multipass QUIC is to let receivers be able to create different paths, which can, for example, have different IP addresses, but also at the transport layer, it will be a different logical path. And here is just to be consistent. But what is important is that currently the specification says that all paths use the same TLS keys, so all paths are encrypted the same manner. And I think the other things are not that important. And the question that we had was, what can we do if we require each of these paths to have a different key? And the answer is that we could have a first pass, which is unique for each receiver with the source, and then have a new pass, the blue one, which will be shared between multiple receivers. And so what we can do is that we can have the destination address of this pass could be a multicast address. So here we would have a pass which is unique for each receiver, and then a new pass which is shared between multiple receivers using a multicast IP address. And so we can do multicast, sorry, at the transport layer. Next slide, please.
Just a quick question: Is multipath quick something different than the multicast extensions to quick that Jake and Max had been working on? Is that this is existing work, or is this just part of the quick spec?
So from the draft, in the draft from Jake and Max, actually we added just a couple of sentences, I think, saying that we can use multipass to do this. Actually, I added this with Max during the version 4 of the draft, but it wasn't detailed how we could manage to make it work.
Sorry, I think Lenny, your question was if multipath quick is separate from multicast.
Oh,
quick.
sorry.
Yeah, and
yes,
multipath
yes.
quick is a separate draft in the quick working group that is getting finished.
Oh, sorry. Yes.
Yeah.
Okay. Yeah. So multipass quick is being being discussed within the quick working group, and they are quite advancing. So we might hope maybe to have a last call. I don't know when, but they are discussing to finish the draft.
Thanks.
Okay. So next slide, please. Yes. So the idea of how it might work is that we have on the right a new receiver that establish a unicast quick session with the source. Next slide. And then the source could advertise that, hey, you can receive this content through multicast, basically. So here is just basically how it already works with the draft from Jake and Max. But so the source can advertise on the unicast pass, hey, you could also receive the content through multicast. Next slide. Then the receiver can say, okay, I'm able, I have everything that is required to do multicast, so I'm ready to join this receiving the content through multicast. Next slide. And then finally, the source can say, okay, so here's the key to decrypt packets from the blue pass. So before the receiver attempts to join, accepts to join the pass, it doesn't have access to the content that is distributed on this pass. And then when it receives the key, next slide, if it will process, for example, making an IGMP join, and then it will be able to receive the packets at the IP layer and then decrypt the packets, and then it's able to receive the content through to this multicast pass. Next slide. And we can do this for all the receivers. So of course the source keeps a unicast pass, a bidirectional unicast pass, so the gray one with each receiver. So it adds a bit of state, but this pass will be only used for control, and the blue pass should be used for data delivery. Next slide. What is also interesting with this design is that at any point, for example, if a receiver has a failure in its multicast distribution tree, it can fall back on unicast, because for the receiver, it's just a multi-pass quick connection. So if this pass fails, the red one fails, it can fall back directly on unicast. So that's why we call it flexible multicast, because at any point in time, you can just say, okay, it doesn't work, we fall back on unicast. And we could also have this with bottleneck receivers, for example. If there are too much of a bottleneck, the source can just say, okay, switch to unicast because I don't want to decrease the overall output of the pass. So you can just do this. Next slide. Yeah, so that's basically what I said. And this is possible because we are using multipass quick underneath, and so we don't have to do a lot of effort to do this. We can just rely on the existing multipass quick draft. Next slide. So that's just some results that I made with so we extended Cloudflare Quiche implementation of Quick, and we made some experiments using a limited setup. Actually, I just got results yesterday with a much larger setup, but it was too late to add it on the slides. But it's yes, it's not that bad. But results here to show that actually, so the blue one is using unicast Quick, and we see that we saturate on a single core using Quiche, and the orange one is showing that we can scale and having a much higher throughput because we are doing multicast at the transport layer and relying on a multicast network underneath. I don't know if I take question now or after. Okay, we'll just finish then. Next slide. So to come back to the previous comment about Jake and Max draft, there are some mechanisms that are already used here that were from the draft from Jake and Max. I do not try to reinvent the wheel. The objective was just to give more detail on how to implement it and how to implement flexible multicast inside Quick, leveraging multipass Quick. So there are not a lot of changes that are required on top of multipass Quick to enable this to work. And of course, I think the best way to continue this work is, of course, again, to merge the two drafts at some point. But because on Jake's Holland draft, there are a lot of security issue aspects that should be reused. But of course, the missing points we have, that's why I come here. Next slide. Is the fact that we need that killer application to enable FlexiCast Quick to work. Oh, previous one, sorry. Yes, because if I presented this at the Quick working group, and so basically the Quick guys were not that much interested in implementing this in Quick because there is not this killer app that we need to make them move, I would say. So either at the next IETF, all the room goes to the Quick working group and we shout that we need this. I don't know, but so that's why I want to present this here, because I'm just a PhD student. So if you have any feedback or any use case, that would be nice. Next slide. So yes, that's just it. So if you have any ideas or use case, don't hesitate to reach out to Max or to me, and I would be happy to hear some feedback about this. Thank you. Oh, so that was backup slide. Sorry.
Turles.
Yeah. Charles Eckert. So I guess the question is whether, for example, something like Quick has a use case to say, replicated unicast, right? So that you're saying I have an application and the application wants to send some data, and on the service interface it says, and here's the list of receivers, and that they would do and be interested to do that even if they don't have any multicast in the network, because then doing multicast would just be an under the hood optimization where we kind of use less bandwidth. Right, so that's where I would start, right? So are there applications where you have dedicated replication, where you basically say the same data needs to go to multiple receivers? We should have that as an extended API for Quick, I don't know, in a data center, Hadoop, or whatever it is, right? And once you have agreement that something like that makes sense, right? Could even be started with these things like joint congestion control, right? That you typically need to have because they go all on the same path and so on. And once you have your foot in the door with that, then the multicast is an optimization that uses less bandwidth. So that would be kind of a path I would take. But still, you need to find your Hadoop or whatever other the application is, right? Maybe it is the video. So yes, that's an application search, and hopefully others here in the room will give you more ideas.
Thank you.
Hi, thanks for the presentation. I already gave a feedback on a Quick working group regarding your use case. I think what's really interesting here is the ability to fall back on unicast. And what I think is really interesting as well is to keep the semantics of Quick, whatever it's using unicast or multicast. So that will be a real nice thing about your work, is to not having to modify the client too much. And I think if you go that way, it will be easier to have people interested in it. And Is it already the case? Can you already run a client with like classical quick semantics, not modifying it and having it work with multicast?
So I had to modify the quick implementation.
Yeah, but the client application, I mean.
The client application, apart from like making the IGMP join, basically it's more or less just creating a new socket, but it's the same for multipass. Apart from that, it's basically the same for the application.
Awesome, thank you.
Thank you.
Tim?
Hi, Tim Chown, GIST. So is the multipath part of this that one path is unicast and the other is multicast? Okay, right, now I understand. Yeah, that's very clever.
Yeah, so for the receiver is just another multipass pass. That's all. So of course, inside the library, we have to make some modifications, of course. But regarding the logic, it's really just another pass for the receiver.
Yeah, I guess, I mean, I like the fact you can therefore fall back to the unicast, but obviously if there were some bigger problem and you suddenly all fell back to unicast, there would be some sort of bandwidth challenges as well. But it's really nice. Yeah, so I mean, the obvious thing is there are some well-known video streaming services that use Quick. Have they tested this or been involved in trialing this to a limited number of users in any way, or?
You mean using Quick for media delivery, for example?
Yeah.
There is a working group called Media over Quicks, and there are a lot of people in this working group. So I think that, I mean, in the near future, or it should be the case. I hope so, because there is a working group about this and a lot of people wanting to make it advance. So I think it will be a part of the future. I hope so.
Good, thank you.
Thank you.
Great. And yeah, this is really interesting. So we do have a global multicast TreeDN network that is kind of ideal for this kind of stuff. Can you talk about what is the state of your implementation? Did you say you have an implementation?
Yes. What do we want to know about
is it in a browser? What can you talk a little bit more about how you've implemented it? Can it is working in the browser? Yeah.
No. In the browser, it would require a lot of things. So first, it would require to have web transport above Quiche, which is it. So I know there is an existing branch to do this, but it's not. I never played with this yet. And then maybe we would have to modify the browser itself to be able to receive multicast packets. So I never played with an actual browser implementation to know how hard it might be. So it should be feasible, but I'm not sure that, for example, if I take a browser right now, I can receive multicast packets. So I'm not sure. And also, we would have to change the existing Quick implementation running inside the browser with the one I modified, because like there were some changes inside it, and because I don't know if browser currently have support for multipass Quick. So I'm not sure currently. So currently it's not made, but it should be possible to do so.
Gotcha. So yeah, I'll be in contact with you. We'd love to collaborate with you.
Thank you.
And Max, if you want to come on up, you basically have 25 minutes, so you can ask questions, cover your three topics, whatever you have 25 minutes starting now.
All right, sure. So maybe really quickly on the browser part, because that's Jake went to W3C even, and so browsers don't have UDP APIs, right? So that's challenge number one. That's why we wanted to get it in Quick. So you can't get multicast in through UDP. To get it in through Quick is also challenging, because as Louis said, you would have to change a lot of the browser implementations of Quick. We tried to do it in Chromium, but the Quick implementation in Chromium at the time was quite a mess. So we stopped doing that. But yeah, in general, there's a lot of challenges. The browser people think it's not a good idea to have multicast in browsers because it exposes privacy information if you join a multicast group and so on. So I think it's going to take quite a considerable effort to get it into a browser, or at least to get it upstream into a browser. Let's put it that way. But even the basic function for a browser would be quite challenging. Okay, so yeah, I'm going to talk actually about one of the scenarios that we had in mind, right? So where do you want MC Quick or multicast in Quick?
And Max, I've passed control over to you, so if you want to give it a shot, see if it'll work.
Let's see. Yes, it does. Okay, so I'm gonna skip over the first few slides because Louis basically already introduced it again. But yeah, there's, as you are all well aware, certain problems with multicast, mostly security, the fallback, and so on. MC Quick, FlexiCast Quick, multicast in Quick can solve a lot of these issues, especially with getting it into a browser through the Quick implementation and preventing integrity injection of packets by third parties and integrity protection, and also making sure you can use reliability by retransmitting packets and all of these things. But yeah, if you have any questions on general questions, as Louis mentioned about the protocol design, I mean, this is the other thing, right? Like the issue here is that we aren't really Quick people necessarily in this room, right? So there might be way more elegant ways to design these things within Quick. So design decisions are still gonna come. We're gonna see how this evolves. We're gonna see if Quick at all, like that's for me is the big question in the first place, if Quick working group at all cares about getting multicast into Quick. If they do, then we can start working with them and getting in there. If they don't, then we might have to reconsider and see what we want to do with this, right? So yeah. Anyway, so I'm going to talk a bit about so how you would actually, if you were to deploy this, right? How it would look like and why you would need that. So one of the things is that if you assume you have one server, right? So you send some packets over multicast, you have one multicast path, and then you have unicast connections to serve like the integrity frames and so on, the keys and all of the stuff you need to serve over unicast. The issue is you still run into a bottleneck somewhere, right? Because if you only have the capability to do it from one server, you're still bottlenecked. So what you want to do, and we ran some experiments with this, we rented a line node and created a bunch of connections, and having them serve the integrity frames, which basically verify the packets you send on multicast to see, so you create a checksum on the client to check that the integrity is correct. This is also in MB, which is now a draft that's somewhat stale, but the idea is, I hope, by now familiar to this group. Anyway, so as you can see, you can't serve that many clients. You can serve more clients than you could serve over unicast if you just send the video directly over unicast, if you just send the integrity, but you're still bottlenecked quickly by the Quick overhead and so on. And of course, this isn't optimized or anything. If you do, you can probably get better numbers, but the point is you still run into capacity issues at some point. So next slide, there you go. So what we had envisioned, one of the scenarios, is that you have this fan out where you have your multicast source, which, if you think about it, one of the obvious use cases here would be live mass media content, right? So think World Cup, NFL, Super Bowl, anything where you have millions or even billions of people watching the same thing, and they do it through their browsers now instead of their TV, and this is where multicast makes a lot of sense. So you have the multicast source in the stadium. By the way, this was published or is getting published this year, and there's a paper if you want to read about it. Right, so you have the multicast source in the stadium, it sends the multicast traffic, and then you have this fan out, which can be a CDN, it can be co-located if you have a small set, like if you don't want to serve 1 million people, just a few hundred, then you can of course do it from the same server, but otherwise you create this fan out server, you have other servers that handle the unicast connection while your multicast source doesn't have to bother with them. The multicast source just has to send certain information to these fan out servers, right? So this is part of the protocol that we didn't actually consider at all yet, right? So how these interactions between the multicast source and the fan-out servers would look like. We're hoping to get it done in near time. But yeah, basically the things you have to do is you distribute the hashes for the integrity packets. and then the fan-out servers handle them. So the question here is, Jake always has the opinion, or had the opinion, that this part should not be standardized at all, that this should all be completely proprietary. But I personally think that it makes sense to at least get people to think about standardizing it, or thinking about it at least in the IETF, if we want to go further with multicast quick. Because this, let's call it backhaul interaction between the fan-out servers and the multicast source is somewhat important. And to me, at least, it's not entirely clear. You probably have a lot more experience with that, what the timing and all of these things would actually look like in these kind of deployments. And I think that's it for the first presentation. Any questions still on anything multicast and quick related?
Could you show, so you had a graph on your first slides, and could you explain the graph, because I could not read the labels?
Sorry. So the blue bar is serving video over unicast directly, right? So the y-axis is the number of clients you can serve. Again, this is like from a cloud provider lineup, and the x-axis is the different ones. So over unicast, you can serve around 52 with this line node. Then if you go to delivering the integrity frames also over unicast, you have this jump, obviously, where because you save bandwidth and computing and all of these things, you can suddenly serve almost 200. And then if you go to multicast integrity, which basically means you also distribute the integrity frames through multicast, instead of unicast, you still get minor improvements, but they're not as critical, because the connection management and so on and quick, just of the unicast connection you still have in the background is eating up a lot of the resources.
So it's the maximum amount of clients that you can serve in each case, right?
Yeah, that we measured on the line node, yes.
Okay. So you did an experiment
Yes.
with your implementation. You have an implementation of that,
Yes.
I think. Okay, cool. Okay, interesting. Thank you very much.
No worries. Yeah. Okay, so yeah, but this is also in the paper. Yeah.
Hi, Tim Chown. You said it would be, or Jake, one of you said it would be good if this approach were standardized rather than proprietary. But which working group would standardize something like that?
Yes, that is also the question. I'm not sure. If anybody has any ideas, yeah.
Just for information, the AD doesn't know.
Yeah.
Oh, well.
But we do. It looks like we have Lucas, and he's maybe the closest person who might know. Lucas, do you have any insights?
The thing here is,
being a working group chair of a working group
a few
that has
yards
working
away.
group in it.
The thing here is that this backbone communication doesn't necessarily even need to use quick, right? This could be anything. So I'm not sure. Yeah, that's the point. That's well, but I don't, maybe even, yeah.
Hi, Lucas Pardew, co-chair of the Quick Working Group. I don't know. This is my first answer. Like, I don't know if the phrasing of the problem is crisp enough for me to understand what's being asked. So that's why I really don't know. But these kind of things, like you're saying, tend to be, at least from my understanding, is working on a company doing more CDN kind of style things, that how you speak between your own services or some other people. Sometimes there's a group like CDNI who might like to standardize some of those interfaces, but there's a lot of other people who just do it privately, however they want, and have the flexibility within their own system boundaries to just do whatever they want. And if you standardize something, they would ignore it anyway and do what they want. So I'm not saying that's the case here. I'm saying I genuinely don't know. If there's ways that you can align protocol on this hop with protocol between all of these others, and it reduces translations and all of that stuff, that could be good. But other times people like have secret source protocols that they use to speak between things, and sorry, I don't know, but I don't know. Very interesting to consider though.
Okay, thanks.
And there's always MOPS. That's somewhat of a catch-all if it doesn't fit into the other quick working groups.
Yeah. All right. on to the next slides. Tolles, sure. By the way, I'll be quick with the other one, so don't worry about time.
But you're always quick here. No, I mean, I think overall the question of positioning is, does this mandate the use of multicast? So this is only for multicast, or as I was saying, multicast is just a way to optimize some dedicated replication, right? So you need so how you phrase the interface to the application determines a lot of the positioning, and so both of them have value, right? In one case, you attach to existing multicast applications and give them reliability. In the other case, you attach to existing unicast application. They never have to know about multicast, right? So maybe both of these models actually make sense, right? But that's exactly going back to the question I was asked in before, right? Identify the applications, what do they like, go to the service model, and then you know what extensions you need to do. And I think you've already experimented with the lower layers of the problem space. I think the higher layers are now what is gapping.
Yeah, thanks. Okay, so next presentation is about survey on the state of multicast support across things, which I think we all in this room know isn't that great, especially in SSM. So this is basically, I hope for this to be a start to produce something tangible, right? Because as I said, we in this room know that this is the case, but there's I'm from research, right? I'm from academia. We always like to have concrete things to point to. And there's absolutely nothing recent in any form of a survey or something that just says, okay, multicast isn't great. There's no multicast support, blah, blah, blah. Right, so I hope this is the start for that. So we had a thesis, somebody did a survey across a lot of different operating systems for what multicast options are there in different languages and so on. And in short, ASM is supported by basically everything, SSM barely by any. So these are the languages we evaluated. We're gonna publish it somehow. So ASM works across IPv4 and IPv6. SSM only works in C, C++, and Ruby of all things on Linux, and only in IPv4 with a small asterisk. There is no, funnily enough, and maybe very surprising, there's an IP join source group socket option that will allow you to join an SSM group for IPv4. But there is no IPv6 join source group call at all in any Unix distribution or in any distribution. So the only way you can do it right now is by using this mcast join source group, which is very, very inconsistently working across different OSs. For example, it's sometimes working on some Unix distributions. It's there on Mac OS, but it doesn't do anything, right? It straight up just doesn't do anything. So yeah, that's basically the state of IPv6 SSM support. And we're trying to get it into as many languages and so on as possible where we can. We added it to Rust, so Socket 2, Rust has it for a while now. But yeah, so that's the state. So why did I come with this here? This is part of the survey, right? That so language support isn't there. But we would also like to be able to point to things where we say, okay, network operators aren't doing multicast, aren't enabling multicast, and so on. And so if there's any operator, any ISP, anybody here that would like to work on this and just create a small paper that basically says, okay, we're not doing multicast because this and this and this reasons, which again, in this room, I think we all know. So, sorry, inter-domain multicast on the internet. Need to be more specific, but yeah, that would be great. So we can have a paper. Yep, all right, that's it.
So I have a question, Max. When you say it's not supported, isn't this a function of IGMP and MLD, IGMP v3 and MLD v2? Or are you saying they don't support source included reports in IGMP v2 and 3 when you say SSM support is not there? Could you just elaborate a little bit?
So I'm saying that there's no way in these languages there's no calls to create sockets or to join multicast groups. So basically the socket options are not there, right? So whether IGMP is working properly or not, but you have no way to interface with it, that's basically. what
So
they-
the OS can handle it, and they can, but the languages can't actually send the IGMP can't interact with the OS in that way.
the languages, the OSs can handle it with an asterisk again, because, for example, if you talk about IPv6 or MLD, macOS probably can't. I don't know. At least the only option, and the other thing is MCAS join source group, right? It's not even documented. It's not like in the manuals it's nowhere. You stumbled upon it somehow. Jake found it originally, and yeah, so yeah, okay. Next. Stick, I guess.
Yeah, hi, Stig Venas. I can't really remember now. I feel like I've implemented IPv6 SSM on Linux many years ago, but I don't remember for sure. So you're saying that the IETF socket API is just not there for v6 SSM?
Yes. Okay, so this MCAS join source group actually comes from an RFC, right? It's somewhere in an RFC, it's specified that that's what it should be, but it's just very confusing because it's not in the manual pages for, again, it's not in the man pages, and it also doesn't really make sense that there's no IPv6 join source group, because there's an IPv6 join group and there's an IP not v6 join source group, but there's no IPv6 join source group. So in all, I think the APIs are really confusing, and I mean, I don't know whose job that is, if that's an IETF job to fix or like reevaluate the APIs that are probably not, APIs are not IETF work, but to evaluate what is going on with the Unix APIs for multicast.
Right. Yeah, I would be interested in looking into it. At least I think our IETF has standardized it, but I might look at that again. Then it's just a question of, yeah, getting Linux or others to implement it, hopefully. At least the language itself can support it, right? It's just a matter of having the correct kernel interface and library.
Yeah, exactly.
Thomas Eckert. So the way I remember it is that when we were writing that RFC for the socket API for SSM, that we were following the direction that we're also using on the socket APIs for unicast with IPv6, and one of the goals was not to repeat the mistake of having to, explicitly support the address family, but to try to abstract away from the address family, so that you're resolving a name to some blob, and then you put the blob into the next API. And that's why there is only a multicast joint source group, which can support IPv4 and IPv6, and arguably you should be able to get a DNS name with a multicast group, but put that in, whether it's v4 or v6, you don't care anymore. Right, so I think that is very well intentioned and good. The fact that documentation is getting written less and less, I can give a big rant about that. As far as the actual support in this is concerned, I'd be surprised to learn if that multicast joint source group for IPv6 is not working in C across these 3 OSs, and yeah, all these other languages, I can easily see how they suck left and right. But if any of these Mac OS, Windows, Ubuntu doesn't work for SSM in C, in the base OS library, I'd really love to hear.
I didn't test it in the last 6 months, but it definitely did not work and did nothing on Mac OS 6 months ago. The option is there, but it just nothing happens. You don't send out any packets. If you look on Wireshark, nothing happens.
Hi, Tim Shane. It's very interesting insights from having looked. I guess you're not familiar with it, you're looking at it and you're trying to deduce what's there. I'm a little confused because I can remember as far as 20 years ago running multicast beacons that were doing v6 SSM, v4 SSM, v4 and v6 ASM. So the software is definitely there. I can't remember what deep beacon, I think was the beacon, what it was written in. Stig had SSM ping and ASM ping that he wrote. I don't know what he wrote it in. I guess he'll come to the mic soon and tell us. So it's definitely there. And there's a video streaming and an audio streaming thing that I've used, but I don't know what that was written in. The other thing I would just say here is that, yeah, ASM, maybe just focus on IPv6 SSM and trying to understand what might be missing that we need to get and where we need to do this. Don't worry about ASM and v4 so much. They're just dead weight anyway. RFC 8815 gives reasons for that. Yeah, let's take this observation on board and try and figure out what pieces are missing. I know the code is there and I know it runs. I don't know necessarily what it's written in. So there's evidence,
Yeah.
prior existence evidence
Yeah.
that people are doing this.
Yes,
But I think your
definitely.
observation is a very interesting one, and we need to make sure that for other people coming like you to this,
Yes.
it's a lot clearer as to what you need to do.
Definitely. I fully agree. It's probably somewhere that just gotten lost in time. Maybe I don't know. Yeah.
So Max, you only have 3 minutes left, and you have one more topic to cover. So I'll let you decide how much of the queue you want. But Kyle is up next. It's up to you how you want to handle this.
Quick.
Okay, sure. Go ahead.
Okay. Yeah, I should have checked this the other day, but it looks like IN6.h on Linux says explicitly that the same socket option is used for both v4 and v6. So it would be joint source group on either.
Yeah.
So
yes.
I don't know if it works.
Yeah. 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 Okay. I think I'm just gonna skip the second talk then and just go. No, you can ask. Sorry.
Hey, Carson, I'll just make a comment that our layer 2 switches, we do multicast snooping, and they do not have support for source specific. So just throw that out there.
They do or they don't?
They do not.
They do not. Okay. Yeah.
So I may not catch your point, but did you check the RFC 3678? This defined the SSM API.
Yes.
And we have two APIs, basic API and advanced
Yeah,
API.
yeah.
And we already discussed that the advanced API is really, actually, the implementation of advanced API is really complex. So many OS may want to just discard that kind of thing.
Sure.
And that kind of also discussion is also described in the RFC 5790, which is a lightweight IGMP version 3 and MLD version 2. It's authored by me, actually.
Yeah. Okay.
So there are several APIs, and there are several APIs should be implemented. It should not be, but it's a little bit difficult to implement. So it's a kernel implementation issue. So there are several possibilities to implement the SSM from the API's point of view. So I don't know, you already completely investigate such kind of situation.
I think that the point I'm trying to make is that it's a mess, a bit around like how you can use it, where you can find it. You have to dig a deep. You can't if you're some normal user and you want to use SSM in your application, or even something you write on Linux in C, maybe it works. But as soon as you try v6 or try it on macOS, you get into really weird behavior and unexpected behavior, and maybe there can be a better job in documenting it and seeing what works and doesn't. But yeah, maybe that's not a problem with the RFCs. I will take a look at the ones you mentioned.
Yeah, and I can just
I'll send them to me. Yeah. Okay. Yeah, that would be great. Thanks.
This sounds like a very fruitful topic. I would recommend taking it to the list here.
Yeah.
And
so yeah, the last one would be about having bandwidth awareness in multicast. Maybe I will just ask a very quick question. Does anybody know if this has ever been done in any kind at the IETF, where you take the sources, bandwidth requirements into consideration when you create multicast trees or anything like that? That was basically what I hope to get out of this. Really quickly. Stig?
Okay, I'm in the queue, I think. Yeah, Stig here. So I don't know if it's really been done in the IETF, but I had a draft in PIM working group just recently where I suggested having some way of announcing bandwidth of a flow. So there's something called PFM to announce like active sources within a PIN domain, and you can have like TLVs for bandwidth and stuff. And I was just suggesting briefly there that, for instance, if you have like ECMP, you could maybe choose to, use a path that has sufficient bandwidth or something like that, or maybe not join if you know that there isn't enough bandwidth.
Okay, thanks. I'll take a look at that.
Tolles Eckert. Yeah, I mean, we've done RSVPT point-to-multipoint, with all the fancy, TE things you can ever do. I'm not sure how much that was deployed. I think there are 2 or 3 implementations available for that. As far as native multicast is concerned, in the 90s, when we had SAP SDP, to announce the different multicast sessions. The router implementations were spoofing on them, and then actually, establishing per flow QoS. There was all software forwarding later, when the hardware was impossible, but that actually did provide you guarantees for the bandwidth of the flow. But those are the two data points I remember of actually having been deployed over years.
Thanks a lot. I will take a look at them as well.
Hi, Craig Taylor. A former colleague at the BBC, I think, presented some bandwidth-aware multicast to DAB. You can probably find some papers.
Okay, I will take a look as well. Thanks.
All right, another great topic to take to the list. Thank you, Max.
Thanks a lot, guys.
Really great stuff. And Nate, there's only a minute left, but basically this is a talk that you're going to be giving in PIM, and we'll give you a minute to tease the crowd to tell them what they should see on Friday.
Yeah, that sounds good. Can you go maybe to slide 4? 2 more. Okay, so what we've been looking at is multicast snooping networks in a default block configuration. And what we found is that in certain network configurations, there are, you're getting multicast streams forwarded up to the multicast router that doesn't actually need those streams. And so what we're looking to do is optimize that away so that we don't get that extra red path there, because there's no need for that. So we'll be talking about that more in PIM. Thanks.
Great. So if you're interested in that topic, be sure to show up at PIM. If you're interested in any multicast topics, please show up for PIM on Friday. And anything else before we go? Any other comments? We had some really great topics. It's not typical that we run out of time. So this was great. Sorry that we couldn't have more discussion, but again, lots of great topics. Take it to the list. And if nobody has anything else, we'll see you all at IETF 122. Thank you, everybody.